In this brief video, I'd like to go over the two major types of questions that we're going to be asking in this course: analysis and design. Analysis is also known as solving a circuit. What this means is to find all unknown currents and voltages. And that's it. So I might draw a circuit and say, solve it. What that means is to find the current through every component and the voltages across every component. Sometimes we might ask a smaller subset of solving a circuit. For instance, I might have a particular circuit and ask, what is the current through a particular resistor? That's essentially solving the circuit, where we're not going all the way if we can. The next thing is designing a circuit. This is where we choose components. And typically, the way we do it is we say there's a problem to be solved, and we want to solve it with a circuit. We've done a little bit of design and a lot of solving in the previous units. In the upcoming units, we're going to continue this. In a sense, what we're developing are the techniques for solving a circuit, and then we're going to learn how we can use those techniques to also design circuits. The upcoming units talk all about resistive circuits, and we're talking about resistors in extensive detail. The reason for that is because resistors have a very special property. They do not store energy. There are many other components that do store energy. The reason that this is important is because they are, in a sense, and I'm going to use quotes here, the simplest circuit element. The reason I'm quoting simplest is because it isn't necessarily fair to say they are simple. There's a rich theory that we need to develop. However, what I mean by this word is that others have more to consider. For example, you may have heard of capacitors or inductors. These two elements store energy either in an electric field or a magnetic field, which makes their analysis much more complex than that of those of resistors. The reason we study resistors is because solving circuits and designing them with resistors is, number one, simpler than using mixed circuits, and number two, comprehensive. What I mean by that is any techniques we develop for resistors with suitable modifications can be used for more complex circuits. So it makes sense to develop those techniques with resistors and then expand upon them when necessary for more complicated circuit elements. But remember, the two types of questions that we're really looking to solve in this course are either to solve a circuit using resistors or any other components we have, which means to find all unknown currents and voltages through every component, or design, which means to present a problem and then to solve it using a circuit.